something like that.
Yes. Okay.
Okay. Thank you guys for coming. Just as the first quick remark, if you have any questions, if you want to discuss anything, just interrupt anytime, okay? So if you have questions, just don't wait till the end or whatever. I prepared actually a couple of slides, but my plan was to go only to a few slides and then do a lot more stuff directly in code. So to make it very concrete for you to get the idea. And that makes it also possible to change the flow at any time. So whenever you have questions, whenever you're interested in some special stuff, just let me know and we adjust to that. So yeah, my personal background, that may be interesting because I'm working in basically BPM and workflow technology for around 10 to 15 years. And over that time, I helped a lot of companies to implement long-running processes. You said something about workflow, process managers, and all these kind of things. So if you think of it, for example, I know Zalando is also active in Norway. So whenever you order something at Zalando, basically the order fulfillment process, that's something I work with to make that happen. Also a lot of telecommunication companies, a lot of them are also active in Norway, where whenever you, for example, apply for a new contract or apply for a new SIM card or whatever, this needs to be provisioned. That's also a kind of a long-running process, a flow, a workflow, a process, how you want to name it. Or insurance, they make a new insurance contract or make a new insurance claims. Every time you have to fulfill something, which if we're going to the DDD world, what we will do in a minute, spans multiple aggregates, for example, and crosses the boundaries of different bounded contexts and these kinds of things. And that poses a couple of problems I want to try to iterate today. Okay? So that's my background. I will directly start with an example because I like examples to make it very concrete. It might be not the most realistic example, but it's a very well-known example, so that makes it a good start. It's a simple order fulfillment process, so that's something you can imagine. You want to buy something, and in the end, you get it delivered. We could imagine to have, for example, these four, let's say, bounded contexts. Like we have a shop or some checkout or whatever it is. We have the payment, we have an inventory where all the stuff is stocked, and we have a shipping where we can really bring it on the road and some kind of parcel. We might have a couple of events on the way, so whenever you buy something, that might just emit like an order placed event. Whenever you pay something, that emits a payment received event. Whenever we have something in the inventory like fetched, we have the goods prepared in order to be shipped, that might be a goods fetch event. And whenever we have shipped, we have the goods shipped event. That's kind of, hopefully, makes sense. Okay, very good. So this is basically how, what I call that event flow, because I had the event flow in the title. That's basically what happens in a lot of systems, not only tied to DDD. It could be also like if you're going to microservices or if you're going to event-driven systems, that's more or less how it then looks like and how you currently design a lot of systems. So you have this event flow, but only the overall flow makes the end-to-end process, the one the customer wants to have at the very end, the goods happen. So you need all of that. So that's an event flow. Okay? So that's what I meant. I wanted to not to do many slides. And what I did, just a quick question, who is programming in Java most of the time? Who is doing .NET most of the time? Who is doing something else? What is that? Like? We're doing PHP. PHP? Okay. Anything else? Any Golang here? No? Okay. I did the most of the stuff in Java, but it's so easy that every C# developer can do it. I have a C# example at the end as well, but I think for the moment it doesn't matter much. So what I did actually is I did a very small example, really tied to the basics, where I said I do everything in one. So I have programmed my own little bus. You see it, it's just a list of observers where I can register, and then I can send an event, which is passed to every observer. So this is something would you normally use something like whatever, Apache Kafka or RabbitMQ or messaging or whatever it is. Something real, okay? But this is for my demo, that's perfectly fine. So that's my bus. And then what I can do is as soon as I have a shop, I can do something. Is that readable from everywhere? From the back? Yeah, okay. So what I can do, for example, I can check out like a new order. And then what I do is I just send a new event to my bus, where I say, okay, I now have an order placed, and I might attach some payload to that event. I just create a random order ID, and that's interesting later on. I have VIP customers and non-VIP customers. We tackle that in a minute. So that's a very simple order, okay? So what happens when I send the order placed to the bus? If you think of the picture we just had, so that means our shop had the order placed. So that means payment now should do the payment. When you implement that in a pure event-driven way, it would mean something like I have the payment. The payment basically I programmed in a way that every component gets all the events. So I listen to the bus, get everything, and then I select what I want to have. So for example, I want to have only the order placed event. Whenever I get that, I do the payment, which I skipped in the example, so it does nothing. We can do a sysout if you like, but I even skipped that, so I was kind of lazy. But this is where now it should do something, right? So do something useful, probably. So retrieve the payment, and whenever that is done, we issue a new event that the payment was received, okay? That goes on the bus. What happens on the bus? The next thing that should happen is in the inventory. Whenever I have the payment received event, I want to fetch goods. There I did a sysout actually. There was not that lazy. And then the goods are fetched. The next thing that happens whenever the goods are fetched is that the shipping jumps in and says, oh, goods are fetched, so I want to ship the goods. And then I'm done. Make sense? Pretty easy, right? I can run that. So I have basically they register on the bus. I create a new shop. And I check out a new order. I just do it. So that's the basic. So what did I change? Some sysouts probably. I run it and that runs. So I place a new order, order placed, payment received, then I fetch the goods, goods are fetched, I ship the goods, goods are shipped. Everything fine, right? So that's a very easy example. And that's actually on a larger scale how a lot of event-driven systems are currently built. So I just listen to events, and whenever they are meaningful to me, I react. Now I want to change something in that little system. That's why I did the VIP customers. VIP is kind of could be also something like you say whatever legal entities can pay via invoice or something like that. I said VIP customers can pay later. So they do something like getting an invoice, pay later. So they don't have what I want to do here is I want to change the event flow. So whenever I have a VIP customer, he don't have to pay immediately at the beginning. That's an understandable requirement, right? So that's a change I want to do in the system. And the interesting part is what do I need to do in order to implement that? So the first thing I have to do is actually I have to go to my payment component. And if you think of it in terms of DDD, that might be a completely different aggregate than the shipping and the inventory, different bounded context, maybe different microservice, different whatever. So it's kind of a very different place here. And I could say something like event order placed, and now I have to look actually in the payload, something like I can get the payload. I did like a map or dictionary if you're in C#, and could do something like get VIP. Right, and that's a Boolean. And whenever this is false, if it's not a VIP customer, I want to retrieve the payment. Only then. So far, so good. That's maybe not yet that ugly, but it gets worse actually. The next thing I have to do, I also have to change my inventory in order to implement it, because now the payment received event I only have it if it's a VIP, if it's a non-VIP customer. And that means I also have to go to inventory and say, okay, either a payment received or I copied not enough, or if event is what was it? Order created and VIP. Sorry again. Order placed, thank you. That's why live coding always works, because you that's like pair programming, very good. And then I also have to fetch the goods, right? And then this will work again. It should actually ship goods, ship goods. So I have a non-VIP and a VIP case. So in both cases, customer gets the order. In the non-VIP, it has the payment. In the VIP, we don't see the payment. So it works. But the thing is, the problem I have with that implementation now is that whenever let's quickly where is that? Where's my code? There it is. Very cleaned up disk here. There. Whenever I commit that code, I see that I made changes to the inventory and to the payment. And that's something for that requirement, I don't see that as a good option actually, because now I introduce a new requirement which has nothing to do with payment, which had nothing to do with inventory, but I have to change both contexts. And in order to get that to work, I have to deploy them at the same time. So I couple them together in a way which I don't want to. If you're like Eric Evans has this picture of the three-legged race, which I like very much. So you basically, do you know these? Yeah. So this is what you do here. So both of them are really tied together. And that's something which is not a good idea here. It might be very obvious to you, but I see it happen very often in real systems that this is really done. So it seems not to be that obvious on a bigger scale. So what you can do in order to remove that burden is actually to implement something or introduce a new notion of a so-called command. You might also know that. So this, we just did pure event-driven things. So we said an event is something that happens in the past. So the payment was received. But I haven't yet introduced something like a command. I command somebody to do something. So I can introduce a command where I say, for example, let's start with the payment. The payment shouldn't listen to something like an order placed thing. We might have to do payment for different things, not only orders. And if I do something like this, it means I have to listen to a lot of events probably where I have to do payment. It makes much more sense to introduce a notion of commands where you say, okay, I have something like, for example, retrieve payment command, probably. So it's not something that happened in the past, it's something active. I want to retrieve the payment. That's something I command to the payment service or context. And as soon as you do that, you get rid of most of the problems here, because then you can say, okay, as soon as I get that, or I think in the solution I have in my Git, I called it retrieve payment. As soon as I have that, all the services are getting much easier actually. So for the inventory, it's something like fetch goods. Easier. For the shipping, it's something like ship goods, probably. So it's much easier. And so the services got easier. But where's the event flow now? So how is it working? I mean, it's not working at the moment. So that's kind of a problem. But as soon as you have these kind of commands, you need or in this example, I would argue that you need an own context in order to make the overall flow. That's something what would I see very useful here, to have something like, I called it order. So it could be an own order context for the overall order. And that could do something like, whenever I have the order placed, then, I called them command, sorry. I issue a command like to retrieve the payment. And then whenever the payment is received, I issue the next command. So I have actually one context which really keeps track of that overall flow. And that makes it much easier actually to change that overall flow, because you have it in one place and you have now one component you can change whenever you want to change the overall flow. So you don't have to redeploy payment just because you want to change that VIP customer thing. You can do it here. And that's a very important thing, and it's very often, I think, at least in the microservice community or in the event-driven community, it's very often overlooked. Maybe in DDD it's not that bad, actually. I think you're better in designing systems than there. But it's important to keep in mind. So you have the notion of a command, and you have that own context for the overall flow. Agreed so far? Make sense? Okay. I briefly changed the stuff that it really works again, sorry. So it's a fetch goods command in the inventory, and it's a ship goods command in the shipping. The only thing I have to add actually is I have now to also start up my order context, my order service. Can start that, and again it works. So I have for non-VIP customer order placed, retrieved payment command, payment received, fetch goods, goods fetched, ship goods, goods shipped. Very well. This is how it should look like. So that's already a much better design. Okay. So far we haven't yet talked about process managers at all, but I think already that improves your overall architecture by far actually. The next thing what we could do, and that's actually a pretty interesting thing. So if we look at that flow here, what we could do, and that's something actually where I come from, that's basically my world. So I come from a world from where we do like using workflow tools, workflow managers, process engines, orchestration engines. And something I use very often actually, because it's by coincidence, it's the open source project from us. But I come back actually to that, why we started that in the first place. So that might be interesting for you as well. But what I can do is, it works a bit different in .NET, in C#. I come back to that in a minute. But in Java, for example, we can start, we call that process engine, but you can also call the pattern is normally called process manager, or you can call it workflow engine or flow engine, orchestration engine. There are a couple of terms out there which are kind of overlapping at the moment. We call it process engine, and we can start that in memory if we want to. It doesn't make so much sense, but we come back to that in a minute. So we can start it by one line. And what I can do here, I can create flows, because that's a flow of events we have here. I could do something like, I call that order, for example. We use something which is called BPMN here. Does anybody know BPMN? See a couple of people nodding, okay. Business process model and notation, yeah. It's the interesting part here, it's an ISO standard, so it's worldwide standardized. We see that in a minute, how it looks like. For the moment, the only interesting thing is the standard, and we use that in the background. But we also provide like a DSL, like a Java DSL, in order to create the flow now. So I could do something like, okay, I have to start somewhere. The first thing I want to do is, it's called service task in the BPMN, so I want to retrieve the payment. Retrieve payment on. Not allowed to do blanks in the ID. And what I can do then is to actually attach code to it. So I could say, okay, in order to retrieve the payment, I have to do something, and I code that actually public static, maybe not the best practice in Java, but public static class, let's say retrieve. I'll leave the typos there. Don't do any harm now. This one does. Implements Java delegate. That's an interface from us in this case. And that just gives you an execute method. In that execute method, you can do whatever you want to. So basically, I just move the code from here into here. I fix that in a minute. And then I can attach that class to my nice little flow there. And I can say whenever a new instance of the flow runs through the service task, execute the code below, which sends the event we already had. The next thing, and that gets interesting now, is we have to wait for the event payment received, right? So that's the next thing we have to do. In BPMN, that means it's a so-called receive task. So I can receive for wait for payment, let's say. And that gets a message name. So we have to name for what message we want to wait. And I just use actually the event name as message name. And whenever we receive that message, the next thing we want to do is we want to fetch the goods. So from now on, it gets more boring, actually. So I might copy a bit. Too many typos today. And I don't do it till the end, actually. I've prepared something which is a bit faster. So we retrieve the payment, we wait for the payment, we fetch the good, we paid for goods. Fetched. For the messages, I have to be precise, so that's good fetched. And I actually have to provide a second class here. So I have to fetch goods, and that's the fetch goods command. Now, interesting part here is that when I later on start new instances of these flows, they can contain data, they can have variables. So whenever I have my event with a payload, I can attach the payload to the instance and get it from that instance later on. So it's called variables in that case, but I think you get the idea. So that should already work pretty good. The only thing I have to do is actually whenever I receive an event now, I want to do something else actually. I don't want to do the logic immediately, but I want to delegate it to the flow, the workflow engine. And that means I go to Camunda, I get to the runtime service. I could either directly say start a new process instance, start a new flow instance. But what's much nicer here is I could create a message correlation. And that's why the message names are important. I think I forgot the one at the start. Yeah, the start event, I also say I start by this message. And then I just tell him to say, okay, whenever this message arrives, set the payload. No, sorry. That's why I didn't want to drink beer. It gets worse then. Get event payload, and I say correlate with results. So that's the API from Camunda here. So I say, basically I pass the message on to the workflow engine and say, do whatever it takes in order to get that event processed. I do the same thing actually when the payment is received. I actually can just use the event name to make it even like copy pastable to all of them. What you can already see is I could easily make that more generic. I don't want to do that now, but it would be actually very easy. And that should already actually work. So whenever I go to my application, I should be able to run. There it is. It cannot correlate my message. Why can't it? Okay, I haven't order placed. That's interesting. Let's see. That's kind of logical. I defined the flow, but I actually haven't deployed it. So I have to say I'm done. Somehow I got interrupted there. Now I have my flow, and now I can tell the engine to deploy that. So there's a so-called repository service, create deployment. I can add a model instance. I have to give it a name, so I call it order.bpmn. It actually has to be named .bpmn for some reason. And I say deploy. So that's what I forgot. Yeah, so let's try to check it again. Now it should start up the engine. It uses in-memory database actually, and then deploys the flow. It starts order place, retrieve payment, payment retrieve, patch goods, goods fetched, and then we stopped. So we haven't done the shipping yet. Okay? So far, so good. The interesting part is what's so interesting about doing it this way? Because you might, okay, you see that the code is not much more, but it's more code than before. Why is it better? That's a good question maybe to ask. So what I have prepared, I've prepared that actually, not to type too much. It's a other class. So basically the same thing, what you already said. So I create a new engine. I configure it in a bit. Actually, for example, I set some database credentials so I can access the database from the outside. I open up a TCP server for the database so I can access the database from the outside in order to see something. And what I did actually, I made the flow more complex. And that's the interesting part, because as soon as the flow gets more complex, it gets hard to code everything in this if this then whatever matter. Then it gets quite hard to see what happens. And what I did is so that's the flow we just saw, but I made an extended version of that actually. So I might just show you that. So you see that's a bit of more code, right? That does a bit more. And let's quickly see how that works. I do a trick actually. I let my thread sleep very long at the end, so I'm still able to connect to the database. So I can see something what happened in the past. And let's start it up. Okay, so we see for non-VIP customers, order placed, retrieve payment, payment received, fetch goods, goods fetched, ship goods, goods shipped. Why is it only one there? But that's an interesting thing. So let's have a look at that. I expected actually a goods shipped event here as well. Now I have an engine running with the database in the background. So I have really state handling in the background. And what I can do, in this case for Camunda, we provide a couple of web tools. And what I do is I start up them in a small Java container and point that to my in-memory database of the currently running process. So that makes it possible to inspect it there. It's not what you do during runtime normally, but it's very convenient to see something. And then I can do something like this. Probably not yet started up. Should be actually faster. Yep. So now the console starts. It sees it's a fresh database, so I don't have any users. I have to create one. Let's quickly do that. I have to sign in. Let's quickly do that. There are a couple of applications we provide. Cockpit is the most interesting one, so there I see what's going on. It wants to have, for certain features, we need a license of the Enterprise Edition. Most of this stuff is there also in the open source one, but just to make sure I see everything. And then I can see my my process definitions or flow definitions. So there's the order we defined. And there you can see also, and that's now starting to get interesting, a graphical version of that. So what you see in the code, let's quickly go to that, is that for more complex flows, you can define them in a DSL or whatever way you want, in a textual format, but it starts to get quite hard to read. And what we do is you can also define it in a graphical format, so you can use a graphical modeler. But what I experienced in the past is that a lot of developers, if you're using graphical modeler, they are somehow frightened of that because they expect some magic needed to be configured in the background or hidden by the modeler or whatever. So whatever it is, yeah, it seems to frighten people a lot. So I normally start using the DSL. And what we do is whenever you use the DSL, we auto-generate the picture. But then you can see when we use the simple flow from there, you see that's all you have. There's nothing hidden behind the picture. We just generate it. And as soon as you start having more complex flows, most of the people start using the graphical modeler because it's much easier to define that there. But it's actually a matter of taste. And this is a more complex flow I talked of. I just briefly, I actually also write them to disk here. So just for convenience, I write a BPMN file, and that I can open in the graphical modeler. And then I can also fix some auto-layouting thing, because auto-layouting is always like a guessing game. We do just best effort. There you can see that I added the VIP. It's called a gateway here, so I go either that way or the other. So that's already built in there. And I added a couple of other nice features, actually, which are normally one step back. So what we just did, even if it doesn't look like that, we now have 4 different bounded contexts running here. So we might have 4 different services or whatever it is between these bounded contexts or aggregates or however you implement them. Normally you're not running transactional. You're very often running remote. You're running in a distributed system. So it's kind of everything can happen there between aggregates. And this makes it very interesting to have additional features like, for example, I fetch the goods and then I wait for the goods to be fetched, and there might be a timeout, for example. I have to handle that. There might be an error. I have to handle that. I have to handle what it's called the Saga Pattern. Does anybody know the Saga Pattern? Yeah, kind of. Maybe half of the people. So the Saga Pattern is about when I don't have distributed transactions, when I don't have like a two-phase commit, something like I can do the payment and fetch the goods and ship the good within one big transaction. If everything happens, I just call rollback on a technical level. This is not the case normally in distributed systems. You don't it just doesn't work technically. So what you have to do, you have to split that or slice that into smaller technical transactions, like the retrieval of the payment within the payment service might be very, very perfectly running in a transactional manner. But you don't have that overall transaction spanning multiple contexts. And that means whenever you retrieve the payment, it's done. You maybe subtracted money from a real credit card, and later on you see, oh, I cannot fetch the goods. I thought they were in stock, but they are broken, or for whatever reason I cannot fetch them. So you have to take correcting actions, and that's what's called compensation. These are compensating actions, and that's what also Saga is about. So how can I do the overall business transaction in a way where I have only small local transactions and adding compensating activities? And that's what is already built in BPMN. That makes it very powerful here. So I can define, for example, for the retrieve payment, I just specify then whenever this needs to be compensated, I just call another service or another interface, another method. And I can trigger that whenever I want. So for example, whenever I have an error later on here, I could trigger that. So BPMN works in a way that whenever you have the black things, that means it triggers something, and the white things means it catches something. So that means whenever I have the timeout, I might do something, and then I trigger the compensation. And the small little nice detail here is actually that I don't have to redo all the logic, for example, about the VIP customer. So this one only triggers the refund if it was done in the past. If it was not done, it's not compensated. It doesn't need to be. And you don't have to implement any logic for that. That just works. And I have all the code I show you today also on GitHub, so you can also read through the DSL definition of it. So it's not very hard, and there you see the same thing, like I have the retrieve payment, I do the compensation part, I define what happens here, so it's quite easy to do actually. And it also works. Yeah, I already run it, right? Right. I wanted to show you cockpit, and this is how it looks like then in the monitoring, and then I can see even like which instances run through in that process in the past. So we have also like the private, like the bribing features for reporting, but it can also look like one special instance and see the exact way it passed through that workflow actually. So we see that was just the happy pass there. And the other one, we wanted to check actually something. So we wanted to check why this one was stuck. No, it wasn't stuck. So both of them ran through actually. And we can also change it in a way where we say, for example, the shipping. No, the inventory. Oh, shipping is last, right? So the shipping might not, sorry. No, the fetch of the goods. This timeout, just in order to see that timeout, it's the inventory. Now that's what I thought. So let's say we cannot fetch it. We just don't send a message back. So as soon as we do that, we can again run it. I defined actually a timeout of, it's an ISO standard, so it's an ISO 8601 something. Period time 2 seconds. So that's what I defined here. I gave him 2 seconds to answer. The cool thing is you don't have to implement anything. So you don't have to implement a scheduler. You don't have to implement like a SLA thing, like a monitoring what happens if the timeout is not working and how many instances are currently waiting there, and all these kind of things are delegated to the engine. That's actually what the engine is doing. And if you look at that, briefly look at that. So, yeah, it's an in-memory database, so we lost all our data. Yeah, I know. But I actually want to keep the code simple to make it easy to play around. So this is where we are now. So both of them basically already went in the timeouting path. And the interesting part is you see it has a different color. That means it's a frequency of the execution. So one of them basically went through it, one of them not. So the first one was a non-VIP customer. And that kind of slow today. The non-VIP had the payment and also got the refund. And the other one never had the payment, so it doesn't get the refund. And that's kind of already built in. Okay, so far, questions? Make sense? That's great. Okay. Okay, so far, I mean, it's not rocket science. We have workflow engines for ages actually. And one thing I recognized is when I dived more into that, that a lot of people are afraid of using that BPM or workflow technology for these use cases. And one thing I think is particularly interesting is if you look at a lot of BPM projects, and I actually was guilty of that in the past very often as well, they would do something like this. So they would say, oh, there's the order process. So I implement or I model the overall order process, talk to everybody who's concerned, and do, for example, whenever I charge the credit card myself, whenever there's a problem, I try to figure it out, and so on, so on, so on. So that's what's happening very often as soon as you introduce BPM in. It seems to be kind of a reflex to some people. But that obviously, I mean, it violates your context. And that's nothing you should do. But nobody forces you to do that. And that's an important message. And that's what a lot of people somehow also oversee. So you could basically, or you should only apply it for what I call local orchestration, or you should only apply it for your bounded context. If you have the order context, that might have that flow embedded, which it needs. Payment might also have a flow. That's okay. But every context has its own flow. And that slices the overall process normally into smaller pieces. And very often you have like a very coarse-grained overall flow making the end-to-end business process happening. That's kind of very often happening, what I see in the companies. Okay, but you have to distribute that over the context, and don't do that like big monolithic BPMN process. That's very important. What that also means is that you might end up with a lot of different engines. And if you're hopping to microservices language sometimes, but if you take that autonomy very, very serious, it means that every team even can decide if they use an engine for that or not, which engines they use, in which version, and all that. So that should be freedom of the context of the team, of the microservice there. Okay, that basically is also what a lot of projects in the past, when they did BPM, they did something like, oh, there's the central BPM engine, and please use that, which is again a three-legged race, because then you tie together your BPM deployment and your bounded context or service deployment, and that's not a good idea. So I see it as part of that service, and that means you might run multiple engines or different engines. But it's not a problem. I mean, it's very easy to do. There are a lot of tools out there, not only ours, ours are the best, but also others, which do that very well, and which are kind of very lightweight, very embeddable. And for me, that's very important to keep in mind, because that's very often that's the reasoning why not using BPMN or not using a workflow engine for these kind of flows. Okay. Okay. There's another thing I actually always talk about when I introduce that, which I call the 7 sins of workflow. So we just tackled the BPM monolith, or the BPM monolith, which is one thing. And the other thing I always see out there whenever I talk about BPM or workflow engines is actually that one. That's a very important one. The zero code suites, you might have faced them in the past. So whenever IBM or SAP or Pega or I have named all, right? It's on video. All the vendors, basically big vendors, go for that zero code strategy. That means they sell you something that you don't need developers in order to do that overall business processes, because you just click them together. For some reason, it never works. It's kind of obvious most of the time for developers. Not so obvious for decision makers, because they get sold something like you get rid of the dependency on the IT. You can now do it yourself with your business people much faster, much cheaper, and so on and so on. I know some of the big vendors, they are even not selling to like CTOs. They are always selling to the business departments, to the CEO. Because I think they know that it's not working technically, but it's still something that's good sellable. But what always happens is that it ends up in IT, because you still have, I mean, if you're running like what I said in the beginning, like the order process of Zalando, or like if T-Mobile, you're having new contracts or new insurance claims or whatever, it's like your core business. These are core business processes which are complex to implement. So it's not easy to click together. And that means these tools end up in IT, and that normally means you're forced to do some proprietary stuff. We call that death by properties panel, because you're not coding anymore. You have to click through a couple of wizards. You're following YouTube videos how to click through these wizards instead of copying just a bit of code into your IDE. You're not using your IDE because you're using the IDE of the vendor. And this basically made a lot of people literally hate BPM. That's what I get out there. Yeah, I see a lot of people nodding, and that's kind of a pity, because there's a lot of value in BPM and workflow technology, and we can leverage that without going the zero code suite path. Just pick the right thing, and have in mind that there's something different, because what normally happens otherwise is that you say, okay, I don't need any engine, but you have these state requirements. You remember that small little follow, like order created, retrieve payment command. You have to implement things like, what happens if the payment is not retrieved? You have to have some scheduling. You have to have some monitoring. As soon as you have state, these requirements always start to pop up here and there. And what happens normally is people starting implementing their own engine. They don't recognize that in the beginning. They recognize it when it's too late. But it will happen. I see that happen like very, very often. Really often. So normally we replace that engine, which is not that easy after a couple of years, because it's basically everywhere. Yeah, and that's what's important for me. So that's kind of the message. So there are other ways of doing that, and it's very valuable to do that, to implement these, Sagas, process manager patterns, the event flows, and all these kind of things. You get a lot of help there, actually. Questions so far?
More interested in mass transit, because that's what I look at, stuff like that. Mm-hmm. Is this the engine you mean, or this is something that you use full engine? We should avoid that.
So what N service bus is doing, it's kind of really on the state management part, like Saga pattern support. It's quite low level, so you don't have a lot of support there. So from my perspective, it's not enough in order to implement these complex event flows, but it's kind of comparable. So what if you look at Camunda, it's a Java engine. So what you need is Java runtime. So whenever you're in the .NET world, we currently always talk via REST, which is possible. I can show you an example in a minute as well. But it means that there's something running and you're talking via REST. Core engine is like a small Java component. With we're currently using a relational database underneath. I come back to that in a minute. We're currently also working on the next generation technology where we basically do event sourcing underneath. But currently the architecture is relational database, could be basically everything which is out there at the moment, and a small Java engine, and then probably REST.
I have another question. You say you can use different types of engines,
Mm-hmm.
and you can use, like, in some contexts you don't have any engine. This means that you have to have an integral sort of standardized integration between all this. So you have to use the same technology to integrate it.
Why do you want to integrate them, or in which way? You're thinking about that picture?
Yeah. So
but that
they need to talk to each other some way. If they use different engines, they still need to find a common language. Like they use the same bus, or they use.
yeah, exactly. But that actually is not part of the engine question. It's part of your architecture question. So you might want to use like a common bus, which would be probably the modern way to go. It could be that you're also basing on the same event store or something like that. I know there are also possibilities to integrate like that, but that's kind of on the application layer. So I see that flow actually helping you in implementing something within the bounded context. I don't see it as part of the overall thing.
So split the messaging part from the closest part.
Yeah.
Okay.
That's what I would do. And then I actually don't care how the message is delivered. So in the Java world, we or events or something like that. Other questions? So I make the slides available. Actually, I talked about most of the stuff, so I don't want to go through these kind of slides here. Probably there. Oh, thank you, PowerPoint. Okay, do it that way. Probably saw that. So yeah, this is me. I haven't talked about me actually very much at the beginning. So I'm also co-founder of Camunda, so that's why I'm quite into that. But I'm doing workflow basically all my professional life, and it really seeing what happens with the zero code suites was really nugging me actually over the time. I wrote a BPMN book, so I was quite into BPMN, and I saw the potential of that happening. And at that time, we had very, very, very low-level open source frameworks. They could do something, but not really much. And that's why we did something out there in order to, at least in the Java world at the beginning, we really fixed something missing there. Actually, we provided something we saw that is missing, which adds BPMN to the game, but also in a very what we call developer-friendly way. So what you already saw, you saw most of it. So if we, and that's another example, we can quickly also look at .NET, C#, that might be interesting. That's a classical Saga pattern, you might know that, right? The hotel booking example. So if I book a hotel, book a car, book a flight. If the flight doesn't go through, I have to cancel the car and the hotel. That's compensating actions. That's a typical example. If you look at it, how to do it with Camunda, you might already know it. So that's the code we already did. So with the service task, the compensating stuff, and so on and so on. We have that on GitHub, so that's nothing for reading at the moment. If you're in Java, it's also pretty neat that you can do a lot of testing, automated testing with these kind of flows. So we have a lot of support for that. To define the tests, to have these nice little reports, what was the basically the scenario we executed, and a lot of things. We are not that good on the .NET part there, so that's basically Java only. But we're getting better and better at the moment to support .NET, because we have more and more .NET-based customers, basically C# customers. as there is nothing really comparable. I mean, you could go, in Service Bus on the other one hand, or something like logic apps, like Azure Logic apps on the other hand, which is kind of based on basically all that BIS talk on workflow foundation stuff. But it's not really comparable, so that's not that powerful yet, or at least yet. So what's done there is that we basically use the REST API. So everything you can do in the engine, you can also do by REST API. You can deploy a flow, you can start new instances. And what we do then is whenever something needs to be done, you can actually, at the moment, you pull tasks from the engine and say, I could do that, give me work. And then you basically tell us via REST API, okay, I'm done. Now we can move on in the process. Or there was a problem. Do something with it. So it's kind of also working pretty well. And what you can see is we also have a C# engine client, so you don't have to do all the HTTP REST low-level thing. And then it's also quite easy to do, actually. Not that easy as in Java, but also quite easy. And then the engine, it depends a bit on how you really want to run it, but most of the time currently it's run in a Docker file and it's just there. It's not embedded in the C# world, but hey, works pretty well so far. Yeah, so that's then how it basically looks like. We're currently relying, details. If you're interested in that, I've also blogged on how to run it in different languages, so you can read that up. Is anybody interested to see that thing live on C# with the Saga example? Or you can imagine? Code. Thank you. We can do that. So it's actually the same thing. So what I did there is, that's a good idea. And the Task Explorer, do a bit bigger. So basically, as you saw on the slide, I connect to the engine client. Oh, this is not good. This is my Azure. It might be still up, so that could work. But we go to localhost. I could log in the REST API. And then I basically do something like I start it up, and then I scan the all the resources, basically in the current assembly in order to find BPMN models, like this one. So this is the Saga definition I had. Then I have, for example, I say I want to have the reserved car. I just name a topic. We call that topic here. And then I can do in my code, I can actually register my worker for the reserved car, and then I say, okay, again, system out println console. And the next thing I do, I complete the work, and that basically gives back control to Camunda and says, okay, this is done, now move on. And whenever I book a flight, that always fails. That means I report back an error. And that should actually work. Let's see. Do I start new instances? Ah, yeah. Oh, yeah, I started a lot of them, I remember. But let's just look at one. So, I start one, I reserve the car, I execute the task, and so on and so on. We can again look at that. Hey, stole me my monitor. Is that the secret signal to shut up, or? Okay. So the same thing, I can look at it from a monitoring perspective. I see actually what happened. With a heat map, I see that I never went to the end, or can look in my instances, and so on and so on. So that also works from the .NET perspective pretty easily. If you're interested in that, that's also on GitHub, so you can check out that code. We also have like another sample application I just did where I do it a bit more realistic, but again, more on the Java end of the story, where I also have the context we just talked about with an engine embedded, running on a database, and then I put Kafka underneath for the event bus. So if you want to see that in action, then you can run all the services really separated using Kafka in order to distribute the events. You could also use RabbitMQ, so that's kind of a switch you can also use there. If you're interested in that, it's also on GitHub. So there are a couple of things you could play around with. For all the engines we have, or for Camunda, for all the examples we have, it always is valid that whenever you run multiple instances, they're meeting on the database. We need a relational database underneath. That's also the current scalability limit we have. So we don't really have a lot of customers hitting that. But it means whenever the relational database is as its limit, it's the limit. So for example, Zalando is using a couple of databases in charts in order to get going. Most of the customers don't scratch the limit, but whenever you have one, it's the database. And what we currently do, and that's a new open source project we started. We just released a 0.11 last month. We are working on that on the concrete code base for around a year, on the concept for around 2 or 3 years already. So we are switching how the engine works internally completely. So we are completely moving to an event sourcing, so append-only log. So no relational database, but putting the logs, running what we now call a broker. So that's the engine then. And we're doing a lot of clustering with these brokers, with these things like Raft protocol or whatever, in order to really make it horizontally scalable. That's something we cannot do in the current architecture, but we will be able to do with that architecture. And then also the game changes, because then that means we have a client to talk to that broker. We're talking a binary protocol there. And that client will be embedded in the application using the flow, defining the flow, running the flow. And that client will be provided. Currently, we are having a Java client and a Go client, and we will eventually also provide a C client, which also makes it possible to have it like a C# client. And then it will be not a big difference if you're using Java or .NET or whatever. But it's a 0.11. So at the moment, you should be a bit brave in order to get going. But we have kind of big projects start using that. So for us, it's kind of, not sure if you know that, but you might know the innovator's dilemma. Do you know that? It's kind of an interesting thing. You have the book. Yeah. That's already a good start. Actually, you don't have to read much of it to get the idea. You can read like 1 chapter. That's more than enough. That picture is the most important one. The book just describes it with various examples, like, for example, the like making photographs with the how's that called in English? Like the non-digital one, the old one, like with film, yeah. They somehow they always try to, so they made good photos at one point in time. Then they got the market got the new digital cameras. They were like crap. You could make like 2 pictures with the SD card. It were horrible resolution, were not good pictures. So basically what the film industry does, it laughed about them and said, okay, this will not work out. Because it started at the very beginning. But after some time, because they made really good progress with the digital cameras, there was a moment in time where the quality was kind of equal, or the price was kind of equal. And then digital has a much better basis to improve on that. So it's the curve basically hits there, and from there on, digital is much better. And as a vendor, when you start looking at new things here, it's too late. On the other hand, somewhere along this time, normally customers don't pay any money for that because the new technology is not that good. And what we're currently doing with CB is basically we start here. So we know that at some point in time, the current workflow engine technology with the relational database will come to a hard limit, especially in scalability, or also in how you run it in the cloud, how you run it, do you distribute it, how you whatever. There are a couple of things what you cannot do easily with it. But that actually doesn't hit anybody today, or maybe 1 or 2 customers we have, but not the mass of the customers. But we know that that will change sometime in future, and that's why we start CB, and we're currently making good progress with that. But to catch up in terms of features and this kind of things, it will take, I think, another year or something like that. So that's what we're currently doing there. But it might be worth to have a look at, or if you're feeling like an early adopter, talk to me. That's also quite interesting always. So that was the very quick overview. So my key message is always like, it's like you can use these lightweight state machines. It's a bit harder in C# if you're looking at Camunda than in Java, but it's possible. It's not hard. We have customers doing that very successfully. They solve a couple of problems pretty well. You have to solve yourself otherwise. We're going more and more distributed today than we ever did in the past. So that means a lot of these problems getting more pressing tomorrow, like Sagas and these kind of things. So it's good to have some solutions ready, and that's I think BPM workflow engines are a good fit there. BPMN is also a good fit there. A lot of the concepts are quite interesting. Just avoid the BPM monolith and avoid the zero code suites, and then it's a quite cool thing. If you're interested in that, I have most of the code I showed today on GitHub. I will put the slides online. If you have feedback, go to the feedback link. There's a nice little form. You can win a book. We just wrote an InfoQ article, which is basically about the topic that might be interesting for you. And whatever you have now, let me know. I mean, we have enough time for questions and discussions. We do, I think, yeah. Thank you for listening. Questions? Yes.
Yeah, so I was wondering, as I said earlier, so we're doing both Java and PHP, but we have quite a lot of PHP code, and we actually did our own engine, Saga engine, this spring. And what we did was basically we did a DSL, like
Mm-hmm.
say not
Mm-hmm.
BPMN, but
Mm-hmm.
our own DSL, and then we had like an external engine, run engine, or you say process engine that's running in F#, actually.
Mm-hmm.
So we have the separation of, you say, the engine and the definition, and you say the code executing each process part. So how hard would it be to say, let's say that we wanted to switch to actually have formal BPMN notation. We will have the process engine that actually runs and do the state switching and keep track of the process itself in Camunda, but run all the code from PHP.
It's actually the same thing as in C#. So we talk the engine by REST. PHP client, by the way, so that's also doable from there. How hard it would be depends on a couple of factors. For example, what kind of data, what kind of payload you transport in the instances of your current engine, how the current workflow definitions are defined. So there will be some work in order to migrate them to BPMN. Also, you have to look at the running instances. So you might have to migrate instance data or running instances to the new engine.
One of the, you say, the core thing with PHP is that, you say, it's not a long-running process. It's every time the test case. What we did is that we averted that relationship. So it's not the PHP process starting calling the engine, but it's basically the engine calling the PHP application saying, have you got a job? And then we will get that job, and then we will trigger the state and run that job, basically. So we have the issue of having an inverse relationship there.
That could make it a bit more complicated, actually. Because from the line of thinking, it's normally like you have the engine is under control, so it's controlling the flow. It wants to control the flow. And that means whenever we do it the other way around, so you have to call them manually. And if you want to keep it like that, like you have it, it could be probably done, but then you have to find some kind of adapter in between to translate that. And how hard that is, I mean, you have to depend on something. not seeing the current code. Should be visible, it's always visible. If you have code with you on the laptop or whatever, we can check out more people later on.
But I haven't done that. So if I can just add another question. So we have like these, you say, cross-cutting process, cross-cutting across the multiple bounding contexts.
Mm-hmm.
Where do you put that process? Because now you put, say, the order process within the order bounding process, but it might have user business process that does not necessarily fit into, say, specifically one bounding context.
Yeah, probably, but I think if you hit a moment where you say, okay, this process doesn't fit any current bounding context, I think you should introduce a new one. Because any process, the process is kind of domain logic. It should use it in a language, and all these kind of things. So that means it has to live somewhere, and it should live in a bounding context.
It also has a state.
Also has state. And that means whenever you see it doesn't fit in an existing one, it might mean you have to introduce a new one. Maybe just for that flow. But I mean, normally then it's kind of an important thing. Like very often you see this coarse-grained overall processes, and that's very often like really core processes facing the customer very often. So they are important. And they only are should have.
I can share my experience that we have some processes running in anti-corruption. We define it as part of the bound context, but it sits on the edge and it orchestrates processes. But this is one of the options I see. Especially this concern with integration with external systems. And we have anti-corruption layer towards external system that translates events from external system to us, but then we have anti-corruption layer inside bound context that actually works with itself. Internalized events. So.
Another question.
I have a question.
Sure.
Because I try to, we use open source components. We use mass transit and autonomous for state machine. And we use mass transit Sagas to orchestrate process. Plus we have a courier add-on that implements the Saga Pattern. So Saga implements process managers and courier implements Saga. That's a bit confusing.
Okay.
Then because of the scalability and also to have this log, I changed the persistence for the state machine to event sourcing.
Mm-hmm.
It just rewriting the repository. And then it sort of solves this issue. So why didn't you go there and just implement the persistence differently instead of creating a whole new engine? Does it also solve some other fundamental problems?
You mean by
by new project? Yeah.
Saga is a complete new engine.
Okay. So it's not only event sourcing, not only addressing scalability.
There are a lot of things different, and especially, for example, if you want to scale there, we also do something like we have that single responsible writer thing. So whenever in like a huge cluster, there's only like one thread in the whole cluster responsible for exactly one process instance. So we can meet there. So it's about eventual consistency and solving a couple of things there. Whenever you do that, you have to solve a couple of problems around message correlation, like getting a message in, which instance might get it because you don't know it in advance. So you have to solve a couple of things very differently to what we do today. And that means it's completely new. It's more like, and it's also more like what, for example, I subject to the Netflix guys. Netflix is doing something with a so-called conductor. Amazon is doing something with Amazon Simple step functions in our code now. So it's more kind of in this league, so that's kind of a different problem. And that's game. Like, it's kind of cool, very interesting. But what I said, we're starting at the beginning again. So we're getting it very stable, but feature-wise, we're
questions? All right, then we're done.
The beer and
Yeah. Yeah.
Thank you for coming.
Okay.
I hope that was informative. Whenever, if you have questions, just let me know. Even afterwards, you find my email, you find my blog, find my Twitter, or whatever. I think it's possible to send me a message. Thank you.
Okay. Thank you.